In section 7.2, we're going to talk about center of mass and center of gravity. In section 7.1, we talked about the centroid itself, which really was just the center of area, or the shape of it. It is independent of density and gravity. And then we're going to now move on to center of mass. The center of mass, of course, depends on the shape and the density of the material and is independent of the gravity of the environment. And then we'll also look at center of gravity, and that depends on the shape, the density, and the gravity, right? It is also sometimes called center of weight. So center of gravity, center of weight. One thing you should know about is density and specific weight. There are these Greek letters here. The first one for density is rho, and the Greek letter for specific weight is gamma. These are lowercase rho and gamma. Density has units of mass per volume, and specific weight has units of weight per volume. Weight, again, remember, is our newtons and pounds, and mass is our kilograms and slugs. So first is center of mass. Again, with center of mass, we have a formula that's very similar to what we had with our centroid, or center of area. Again, we have the two methods. One is by composite shapes. The other is by method of integration. We will concentrate primarily on composite shape uses of center of mass. In here, again, we have in the denominator the total mass. In the numerator, we have the sum of each of the little individual components that we break it up into of the x tilde, so the center of mass of one component to the y-axis, and then we have the center of mass of another component to the y-axis, and so on and so forth, and we'll add all of those up. Likewise, for y bar and z bar, y bar, of course, would be the sum of the y tildes times their individual masses divided by, again, the sum of all of the masses of the object. And then our z bar, the center for the z direction is the sum of our z tildes times the individual masses divided by, again, the sum of the whole masses. Okay, so those are the equations, and again, primarily we will concentrate on looking at the formulas themselves of composite shapes. So if we look at this little mini example, you will see that we have this shape over here, which has a solid volume here of the cylinder. We have some wire, and we have some surface or plate. Notice, though, with this we're going to use density. This density is mass per volume. This wire is very thin and round and long, and is really just mass per length. That can be a type of density. Typically, this is what we normally find, but you will also find these in this type of range also, like this bottom plate is mass per area. So if we look at that, we have three different components: the solid, the wire, and the surface. We can find, again, so we're going to sum up our masses from 1 to 3 for each of these objects. And if we look at this equation, what we have is the density of the volume times the volume itself. Then we have the density per area, which is that surface plate, times the area of the plate. And then last, we have the length, the density per length, times the length of the wire. Okay, so now if we look at the numerator, we have our x tilde, which is, again, the distance to the, in our case in 3D, YZ plane. So that x tilde for the solid object itself, the cylinder, times, again, its same value of rho, its density times its volume. So that is this distance here to this plane. Okay. That is our x tilde 1. Likewise, for that surface on the bottom, x tilde 2 is for that surface. Again, that's the distance to the xy plane. So that's x tilde 2. And then last we have our wire, and this is the x tilde for the wire. So that is that distance. Okay, so if we had values for all of this, we could then solve for our x bar, and we would know where the centroid was in our x distance. You can do the same thing for y and for z. Next, let's take a look at center of gravity. Again, this is very similar to our center of mass, or center of gravity, or sometimes, again, it's called center of weight, right, because it's in units of newtons or pounds. Remember, if we have the density of the object also, if it is a volume density, we can multiply times its volume, and we get our center of gravity. So this gamma is our center of gravity. And again, the equation is very similar to what we've been using before. We're on the top, we have our x tilde or y tilde or z tilde, depending on which axis we're looking at for our center of gravity, divided by the overall weight of the overall system. Okay, so let's look at this same example again, and we see from this example we're looking for center of gravity. It is the same type of thing that we had before. We have our weight, our specific weight for this object, for this cylinder, is weight per volume. This particular surface is weight per area, and then the last for the wire is weight per length. Don't just assume that if you see a wire that it is weight per length. It may have up a volume value. You just need to know what the diameter is of the wire so you can be able to calculate the volume. And then again, we have the exact same equation that we did before. I'm not going to go through all of that. But please take time and look at the example below on how to solve these types of problems.